Whoa,
Sweet.
so official.
Okay. Yeah, so official. So today we have Pedro here from the Remix team, and he's going to talk about HMR, and we're all very excited to have him. And whenever you feel ready to introduce yourself real quick, be free to get started.
Okay, yeah, let me see. Actually, I have slides because I made some for part of this talk earlier. I have no
Nice.
idea how they'll share over over all of this. So let's try that.
That was easy. We can see your screen.
That's easy. Okay. If I present, I'm guessing, can you see, does that look nice?
That looks amazing.
Okay, great. All right, yeah. So yeah, I'm Pedro. I'm working at Shopify and Remix. Hope that's not news to anyone here, but in case you forgot, working mostly on compilers. Speed stuff has been top of mind recently. And a lot of that has been integrating with Veet's HMR and building HDR for Remix on top of that. So kind of want to talk about HMR because really like a year ago, I had this question. It was like Christmas last year, a little before, and Ryan was like, let's just do it. Let's just like tackle HMR. For a long time, we were thinking about, oh, live reload is good enough and who really needs it. And we're kind of just lying to ourselves a little bit about the necessity for HMR. Anytime you've got really dynamic browser state, you're going to really want something like HMR. So I was like, okay, let's look into it. So, something I always like to ask especially when I've got like a captive audience here, maybe in the chat, just tell me if like, do you know what HMR is? Like, if you're confident, can you maybe put a 1 in the chat? If you've maybe used HMR before in Webpack or Veet or something, can you put like I don't know. I'm like not a live streamer, so I don't even know what to ask people to put, but maybe put a 2 in the chat for that. And if you feel like you could explain HMR to a coworker, put a 3 in the chat. And can I even see the chat? I don't know if I can see the chat. So help me out, Andre. What is it looking like over there?
Let's wait a sec.
Oh, I can see it. Okay.
Mark is bragging, obviously.
Okay.
We have a 0, 2, 1, 1, 2, 0.
A 0. Yeah, I love the 0. Okay. Yeah, so, oh man, I can't even see my mouse. Let me just close out of that and come back in here. So yeah, so some people think HMR is the same as live reload, which is a common misconception. We're not really helping in this regard because we're kind of abusing our own live reload component to do HMR. So in Remix, in your root route, you might see that live reload component. But this is just a common misconception everywhere. So let's talk about a little bit of what difference is there. And there's also this thing called React Refresh or React Fast Refresh, and people think HMR is that. I'm actually curious if anyone has thought about HMR in the context of servers and not just browser to server stuff, because that's the other thing too, is like people think this is like a concept for browsers and web apps, but really it's just a concept for JavaScript, and it works on the server just as well as it does on the browser. So that's another misconception that I kind of want to clear up. But at the end of the day, that I think the best way to understand anything is to just go ahead and break it down. So HMR, it stands for hot module reloading, right? Actually, that's wrong. The R is not reloading. The R is replacement. And that actually will make a big difference when we look at how do we implement this. So when I started looking into implementing this, I did a quick search and I was like, all right, let's see how HMR works under the hood. So I searched it, and you get like 99,000, I guess it says, what does it say there? 7 million results in 0.3 seconds for HMR. And pretty much 99% of that is like, oh yeah, this is how you use HMR. Like, go ahead in your config, set hot to true, and it works. I'm like, okay, thanks. But like, I want to know like how to make it myself, like how to make that be the case for Remix. I can't just put hot true in Remix and expect that to work, right? So I started digging a little bit deeper, and I found a couple of good blog posts about HMR, but a lot of them were really specific to Webpack. Webpack was one of the pioneers of HMR. So I looked at some of these blog posts, but yeah, just really, really Webpack specific. I didn't know which parts of this I could take and use in Remix and which parts of these really assumed you were using Webpack. So That didn't really help too much, but it did lead me to there's documentation in Webpack for hot module replacement. So that looks promising. So I started reading this documentation, and sure enough, it says HMR, hot module replacement, exchanges, adds, or removes modules while an application is running without a full reload. So that without a full reload is kind of the key. So I'm feeling pretty good. I'm scrolling down the page and I'm going to figure this stuff out. And pretty immediately, I start running into things that make me scratch my head and ask further questions. And I'm not really answering any of my questions. I'm just getting new questions thrown at me. So they're talking about an HMR runtime. I have no idea what that is. They're talking about updates. Don't know what format those are in. Like, what are those all about? And you have to apply the updates, which if you don't know what the updates are, it's pretty hard to apply them. Okay, so maybe like this will be clear if I keep reading. Then they talk about manifests and chunks and what is this? The chunks contain code. Is that like executable code, or is that like the code as text? Like, no idea. There's module IDs and chunk IDs, and like chunking is like it's a bundler concept. Does HMR only work with like bundlers? So I'm still kind of unclear about what's going on here. Keep reading. There's an HMR interface. There's this stuff about bubbling up. Still feeling pretty confused. And then I get to the last section, and I love how it starts. It says it gets a little bit more technical. So I'm like, oh, okay, great. So if I didn't understand before, I must have been really an idiot. But now, now I should clear things up. So they're talking about a module system runtime. You have to invalidate things. Like, man, it just got really complicated. So I found one more resource as well, which is a blog post by the creator of Webpack. And this is the diagram they give for explaining what HMR does and what it is. And don't get me wrong, like this is a great schematic if you've worked with HMR before and want to know like some nitty-gritty details. But as a learning tool, this was not at all what I was looking for. And so to me, it really felt like I was asking, how does a differential work in a car? Like, how do cars make a turn when you turn the wheel? And some people are like, well, you turn the wheel and the car turns. Like, what more do you need to know? Which is kind of like the first results I was getting. And then if I asked any follow-up questions, it felt like the answer was like, well, just look at the schematic and it's obvious, right? And there was no in between. So I'm looking for something kind of in between those two things. So here's an example of what I'm looking for. So here's how a differential actually works. You've got this rotating rod, and it can drive these other two rods. And when it drives those rods, like the wheels turn and you can go forward. But if you're turning, one of the wheels is going to turn a little bit less. And so as that one turns less, the other one can still be driven forward. And same thing with the other one. So that's really nice. And, you know, there's a problem though. If you go too far, then you're going to lose contact with both of the rods. So yeah, like that. So you're not going to be able to drive the wheels anymore. So what you need is to add a couple more spokes. And that way, when one set of spokes loses contact, the next set of spokes makes contact, and you can continuously drive the wheels, even when one is stopped or moving slower than the other. And so that's how like the back axle of a car works. And I think this is just like beautiful. It's just like removing all the complexity, and it's just showing you kind of the core essentials of the problem at hand. And this really makes me understand things better. So this is what I wanted to do with HMR. So before we actually dive into HMR, let me just show you a little demo of the setup that we have so that you can get a feel for what we're doing, because really browser and the network are pretty complicated, and I wanted to boil this down and make it really simple. So instead of using the browser and the network, I've just got a little app here that I'm going to use in my terminal, and it's supposed to kind of emulate a web app. So let's make this a little bigger. There we go. And let's make another browser here. Okay. So here's my browser. I can even make that a lot bigger. There we go. Here's my browser. Got a little app running in it, and everything in red is like an interactable element. So obviously in the terminal, I can't click on things with my mouse and make them do anything, but I can type things, and those are the things in red, and I can do stuff with that. So let's go here, and I can rename this to Andre. There we go. And let's give Andre a little bit more health. And, you know, Andre has to go attack some ogre or something. So we're going to roll some dice. And, you know, he's doing pretty well. Oh, but there he didn't do as well. So, you know, just a little app that's built in the terminal. And let's actually look at like how this is implemented. So what this is supposed to look like is really similar to a normal React app. So if we look at our app index, we've got a component, which we're all used to. It's just a function. And Here we're kind of laying things out in block style. So everything in the list gets laid out one on top of the other. And each of these is actually a component too. So you can do composition of components just like how you can in React. And if you look at something like the title, we've got some state. We've got a way to change that state. And then we can actually, let me just move this over here so it's a little clearer. I'll move this one over here. I've just got the zoom window there. And then, yeah, here's the title. So we've got an inline. So we want to do this horizontally. We've got the name. We've got an input. And we pass it the current state, the trigger that we want, which will show up as this red N, and then the rename function, right? And then the same thing is true with the health. We've got some state. We've got things to update it. If you've ever used Elm, this is actually really similar to the Elm architecture, but it's, again, just kind of a React thing, right? It's just like a component as a function, and then on-click handlers and use state inlined here. So that's all that this is. And so the question is like, how can we get this to a point where if I go here and I change health to blah and I save, I automatically get that update. So you saw that come in right here, right? So that's what we want to do. So let me show you how that works. But actually, before we look at how that works, let's just make sure we understand what's going on in a normal case. So rather than have this solution, let's go and check out the starting. Let's go back to the app before HMR is, oh, I see, I already checked everything out. Perfect. Yeah. Let me just copy this one over here. Yeah, perfect. Okay, cool. So now I'm just in a state where I have the app running. I can still make all the changes I could before. But now if I go back and I go to health and I change this to blah, like nothing happens, right? So now this is back to kind of like a normal state where we haven't implemented HMR. So what we're going to do is we're going to implement HMR from scratch. But before we do that, let's just look at how a normal module system works. So without HMR, when I run the app, it looks at my index because that's like the root of the app, and it pulls up that code, it parses it, and it executes it. And as it's executing that, it runs into some requires. And so every time it runs into a require statement, it's going to go ahead and do the same thing. It's going to pull up that file, it's going to parse that, and it's going to execute that. And the same thing happens for my health and for the roles. And so now if I make a change to something like the title module, well, the only way to pick up those changes is to actually do like a full restart. So if I go back to my terminal here, if I, let me actually edit here. If I go to health and I change this to wow, like now if I rerun it, of course that change will show up. But then if I change it again to blah, it doesn't. I have to manually go in, kill it, restart it, and pick up those changes. And when I restart that, it's going to do the same thing, right? It's going to rerun the app. It's going to relook at those requires and get everything. But this time it's going to pick up the new title because that changed on disk. So that's kind of the key takeaway here is like when things change on disk, Node doesn't care. After it runs your app, it already has an in-memory representation of your code. And so as things change, it's not really caring about those things. So how can we actually do a little bit better? Well, with live reload, we could auto restart every time a change happens. And so we can make this automatic. But the issue is like restarting wipes away all of your state. So let's just see that really quickly here. So if I have something like in my app, I'm going to change it back to Andre, and let's make him get hurt this time, and let's make him roll some stuff. And now if I change this back to, let's say, life points, and I save that, nothing happens. So let's restart. But now, of course, I lost Andre, and I lost all my rolls, and I lost my health that I had before. So even if this was happening automatically, like this isn't great either. I'm losing all that state. So what does it look like with HMR? So with HMR, I have my app running. So I just skip through that process again where it loads the index, and that requires all these 3 other modules. And now a change comes in. And what we're going to do is we're going to take a page out of Indy's playbook, and we're going to just change the thing we care about. And everything else is going to stay the same. So this slide might look familiar to some of you if you were at RemixConf. So let's see how that works. So this time we're going to change title, and we're just going to like somehow remove it from the module graph. And we're going to bring up the new title. And it's just hanging out there in space. We have to get the app to kind of draw that line from index to title again. So we're going to re-require from the app index to the title. And that should somehow, let me go back. Yeah, that should somehow make this link. But how is it going to know to re-require the title? We're going to need some mechanism where when the title changes, we're going to have to somehow know that because the title changed, the app should be the one to re-require and not health and not roles. And this goes kind of recursively upward. So if the app had it was dependent on by something else even higher up, we'd have to have that whole chain re-require all the pieces all the way down in order to pick up this change for title. So if that doesn't really make sense to you, that's okay. We're going to do this in code in a second. But the whole point is like, we're going to somehow remove our modules from the graph, make a new one, and we're going to have a chain of re-requires to rebuild all of those links we lost along the way. And that's how it's going to work. So yeah, we need some kind of fine-grained way of re-requiring just the modules that changed. That's kind of the key takeaway here. And we're going to do this all in CommonJS because CommonJS makes this easy and really explicit. Because CommonJS has a require.cache, and that gives us explicit control over what require is doing. When you require a module, is it going to use the cache? Is it not? And that's going to give us the control that we need to implement it. So let's go ahead and implement HMR. Let's go back here. Let me change this back to health. And let's go look at my to-do list here. So I've got this repo that you can actually go and look at the code that I'm about to use right now. And it's got this README, which has the solutions as well, linked to, but it has everything laid out kind of as a workshop. So let's actually just do it together. So we've already run the app. I've already gone ahead and done step 2, which is add the new component for the dice rolls. So you can see the rolls showing up here. If you wanted to do that on your own, you can go ahead and go into the app and look at rolls. And right now it's just stubbed out. So you can go ahead and add that. And that's just to give you a little bit of familiarity with the components that we're using. But let's go ahead and go to step 3 here. So let's go watch for changes in the app directory. So the first thing we need to do is we need to know when the changes even happen so that we know how to react to them. So let's go back to the run function. This is the thing that I'm actually running when I run this app. And you can see what it's doing is it's requiring my app component. So again, this is a function, just like how it would be in React. And we've got this little like browser implementation, which is the thing that knows how to draw things on the screen here. And it knows how to do 2 things. It knows how to render a single frame of our component, and it knows how to run. And what run means in this context is it has like the event listeners for when I press R or N or plus or minus. And so it knows how to handle those things. So yeah, instead of letting require do all the heavy lifting here, let's actually re-implement this. So let's comment this out. And we're still going to need to run, and we're still going to need to render things. So let's just set that up. Render, return, render app. But this time, every time we make a change to the code, we want kind of a new version of the component for the app. So we're going to have some way to get a new version of the app. So let's just make a getter like that. And we're going to need to call something like let get app equals HMR, and then we'll do app index like that. Yeah, there we go. And this will be an async function. And because we're in CJS and we don't have top level await, let's just wrap this in a main like that. Let's go down here. Nice. And then we can just call it. So HMR is going to give us like a handle that we can just keep getting new versions of the app every time things changes. And then we're just going to pass that over to the browser. And then every time it wants to render a new frame, it's going to call this function that we're passing here. It's going to grab a new version of the app, and it's going to render a frame with that new version. So now let's go ahead and implement HMR. And specifically, we're going to get that from, yeah, that looks good. But we're just going to define it in the top level. So let's just do it like that. Perfect. So now let's go into that file. So here's our HMR file. This is exactly the function that we're using here. So let's just do something really simple. Let's just say return. We need a function, obviously. And let's just make it require the entry point. So right now, we're not doing anything fancy. We're just doing a pass through. So it should work the exact same way as it did before. And yep, looks like it's still working, right? So that looks good. So let's get started. So let's watch for changes in the app directory. Let's use Chocodar to do that. So let's go ahead and do something like let app directory equals path.join. Let's just be quick about it and use the current working directory and then look for apps, since we're always going to run this from the root. So we're not doing anything too fancy there. Then let's set up a watcher with Chocodar. And let's say ignore initial true. That looks good to me. And that's just going to tell Chocodar, like, don't emit watch events when you start up, only emit watch events as files change after you've started up. So that's a little implementation detail of Chocodar. So now we're going to say watcher.on, and we're going to say when any files change, I want to be notified of them. So now let's just go here and let's just make sure that we're doing this correctly. So let's just say change file like that. So now if I run my app, and then if I go to something like health, and I change this to blah, there we go. So we can see that file changed. Okay, so that's step one. So we've watched for changes, and let's re-require the app. Yeah, that's fine. So now let's go ahead and invalidate the whole app. So like I said before, if we just if we go back to our HMR function here, we are re-requiring the app every single time we call this getApp function, right? So every time this runs, we're getting a new version of the app because we're re-requiring it every single time. But there's something that requires doing for us, which is it has a cache. So after it requires something for the first time, it's going to give us back the same result every single time. And that's not what we want. We want to get new results. So let's actually just do that real quick. So let's say something like let invalidate all equals, and let's just say something inside of like the app directory. We're going to invalidate all the code inside of our app directory. So let's say something like for let key of require dot cache. Whoops. Require dot cache, and we'll say object dot keys like that. Okay, and then we'll say if key dot starts with the app directory. So these are going to be full file paths. So if the thing that we're caching starts with the app directory, then we're going to go ahead and delete that from the cache. And that's how we're invalidating everything. So let's go ahead and just do that here. So let's say invalidate all after. Okay, so now if we run this, and let's just like make some changes here, and we've got 30, and let's go back to health. And if I change this back to health, so we picked up the change, we invalidated the cache, but the thing is, like, the browser itself isn't getting a re-render yet. It's not getting a signal to re-render. So if it re-rendered, it would have the updated things, but we need to tell it to re-render now. I actually have a little shortcut built in where if I press enter, it does a re-render, and you can see it picks up health. So that's perfect. That's exactly what we want, but we want to do that automatically. We don't have to want to press enter every time. And that's the next step here. So let's trigger re-renders whenever things changed. So now let's go back to run. And luckily, we have a socket abstraction inside of this browser library. So let's use that. So let's grab socket. And this is literally just the thing that has two functions on it. It's got a listener and it's got something to send a signal. And every time any signal at all gets sent over this socket, if we pass that socket to the browser, it's going to re-render. That's like the only thing it can do. So let's just do that real quick. So let's make a new socket. I'll pass it in to run. The browser run function already knows how to deal with sockets, so it's going to just wait until it receives a signal, and it's going to trigger a re-render when we do that. And let's just pass in the socket to our HMR function. So now if I go to HMR, I'll just add something like socket here. And after we were invalidated, let's say socket send, and we don't even need to send a message. Let's just do it like that. So this should trigger a re-render for the browser when we change anything. So let's go here. Let's go to health, and let's change this to life points. And there we go. So now we're getting updates showing up. But again, if I make some state and then I change it to health, it's losing that state. So right now what we've done is we've reinvented live reload. So that's really nice. Now we know how that works. So this is the entire implementation for live reload. Not too bad. Just watch for changes, invalidate, and then send everything. But we're invalidating everything here. So this is kind of like the problem. We want to just invalidate that title or the health or just the module that changed and not all of the modules. So that's going to be how we go from live reload to HMR. So let's do that next. So let's invalidate only the changed module. And, in order to do that, we're also going to need to bubble up, like we saw in the presentation earlier, to all of the dependents of that module. We're going to have to invalidate those. So how are we going to do that? So let's make a function and we'll put it up here and we'll call this invalidate. And this is going to take a module path. And really, like, we'd love to do something like require cache module path, and then just delete that one, right? And now we're doing a more targeted delete just for that module, but somehow we need to also invalidate all the modules that depend on this one. So that's kind of the tricky part here. So if only there was a tool that knows how to like crawl all of my dependencies and could like give me information about that graph, right? That index depends on title and it depends on health, but health doesn't really depend on anything. Like I want something that can give me that graph programmatically. So it turns out that ESBuild is such a tool. Bundlers are really good at this, and ESBuild's a fast one and a pretty simple one. So let's use that. So I'm going to make a function called analyze that's going to analyze my entry point. I'm going to make this an async function. And I'm going to make result equal esbuild.build. I misspelled that. Esbuild, like that. And there's a couple tricks here. So the first thing that we're going to do is we're going to say bundle true. And that's going to let ESBuild actually crawl the dependency graph. If you set this to false, it'll only look at the initial entry point. We want it to do the work of crawling all the imports and figuring all that stuff out. We don't actually want it to write anything. We just want it to like report back some metadata. So we say write false. And to get the metadata, we want meta file to be true. And then there's a couple more things. We obviously have to pass in the entry points. We just have one. This is where I always forget this incantation. So luckily I have it here in the notes. So yeah, we're doing this on Node. By default, ESBuild does this for the browser. So we're just doing it for Node here. And then the other thing is like, just, ESBuild, you can just shut up about everything. I don't want you to complain about weird things not missing or whatever. This is just like a little toy app. It's fine. So now we've got the result, and let's actually take a look at the meta file. So let's say something like for let, let's do that, inputs. And instead of key, let's say something like input meta, and let's say entries. And specifically, I'm looking at the meta file input. So this is where that graph information is going to be. And let's just log out input meta like that. Okay. I think that's pretty good. So now let's just go to the top here. And let's not actually use that information. Let's just call it and see what happens. So let's say, oh, wait, analyze entry point like that. Perfect. And I'm just going to throw an error because I don't want this to like actually render a frame and like write over the things we're about to console log. So I'm just going to say stop. Nice little trick. So if I do that, let's see. Yeah. Okay. Result meta file inputs. I need to await this thing. This is a promise. There we go. Perfect. Okay. So now we can see something like the app index depends on the app title. It also depends on app health. It also depends on app roles. So this is exactly the information I want, but I want it backwards, right? What I want is when I'm editing app health, I want to know what things depend on me. So I want to know that app index depends on me when I'm editing health. So I want kind of the inverse of this thing. So let's just build that up here. So let's call something dependence. And this will be the data structure that we're using. And then let's say for let imp of meta.imports. And let's say something like let key equals path.resolve imp.path. So we want like the resolved version of this path. Right now it's giving us this relative path, but the require cache works with absolute paths. So let's just make sure we convert all those things to absolute paths. And then let's just add those things in. So let's say dependence key, and we'd love to say something like push path.resolve input, exactly. But what if we haven't seen this key before? We got to make sure that we initialize this to like an empty list. So let's go ahead and do that. So let's do something like this. Perfect. So if it already exists, we'll keep it. If it doesn't exist, we'll make it empty. And then we're going to add our paths to that. So let's actually return that. Dependence. Nice. Now let's go up here and let's get our dependence. Now let's just console log those and make sure we're doing exactly what we think we're doing here. Cool. So now we can see something like this library file that we're using is dependent on by the title, the health, and the roles. And that's right, because each of these is importing like button and things like that. We can see things like the roles is dependent on by the index. So this is perfect. Now I have the key of the thing that changed to all the things that need to be invalidated for that key. So that's what I want. Okay, cool. So now we can do our work of actually invalidating. Let's actually put this in here because we're only going to need it right here. And I'm going to teach you guys a little bit of algorithms, which I know none of you signed up for, but it's a little bit required here. So we're going to use a queue. And because I'm feeling cheeky, I'm just going to call it queue. So this is just going to be like a list of things we still have to invalidate. So at the beginning, it's just the thing we want to invalidate. And as we're invalidating things, we're going to add to this list the things that depend on it. And that way we'll keep track and make sure we bubble all this stuff up. So let's say while the queue.length is more than 0. Let's go and put this in here. So now let's say let mod path. So this is the actual one we're going to operate on. Let's go ahead and invalidate it. Perfect. And then let's go ahead and get the dependence of that thing. And it could not have any dependence, so let's make an empty list. It's warning me that this has to be async. There we go. And all we're going to do here, really easy, is we're just going to say queue.push the dependence. So if there's any things left in the queue that we have to invalidate, let's get that thing, let's invalidate it, and then let's get the things that are dependent on from that thing, and let's make sure we invalidate those too. And this little algorithm will just make sure to crawl that tree upwards for us. So that's really nice. Cool. So now if we go here, we can change this to invalidate. And instead of the after, let's just invalidate the file. And let's go ahead and comment this out. And let's try running that. Okay, so it looks like it's working. We can set things like Andre. And then if I go to health, with any luck, I can set this to life points. And I forgot to do one thing here. This is an await, yes. And this should be async. And we don't need this anymore. Okay, there we go. So let's do that one more time. Let's go here. Let's say Andre. Let's make some roles. And then here I can say blah. Nice. So now we're persisting the state in our app and getting those updates coming through. So that's HMR. So if you look at our file here, let's just review what we did. We were just watching for changes, and then we invalidate that file. Our little algorithm is going to look at any of the recursive upwards dependence of this file that we're invalidating and make sure to invalidate those too. And then we're just having a function that can give us a new version of the app every single time. And that's pretty much the gist of it, right? Like the main core piece here is knowing how to get the dependence, which, like I said, bundlers do this stuff really well. If you didn't have bundlers, you could write some parsers and do it yourself, but that's kind of annoying. But, you know, there's one last thing that we should address here, which is like, let's say I actually changed my health here, and then I go back to my health, and I change this back to life points. Yeah, so we lost the 35 health that we had, goes back to 30. So why is that happening? So the issue is we're invalidating this entire module, which includes the state. And so when we're trying to change the UI, it's also invalidating the state. It's like rerunning this whole module. It's resetting state back to 30. And maybe that's not something that we want. So one thing that we could do here is we could make something like health.state.cjs. Actually, let's do an example with roles, because that'll be a little bit easier to deal with. Yeah, okay. Let's go ahead and open up roles. Yeah. So now let's make something like roles.state.cjs. Let's make that file. Let's go in here, and we want a persistent reference to this thing. So I'm just going to export something like state like that. And we're going to say value is an empty list like that. Perfect. And so now here we can say let state equals require dot slash role state. Now we don't need this one anymore. And let's just make sure we say dot value over here. And let's make sure this one also says dot value. Okay. And I probably forgot to do this in one place. Oh yeah, of course. We're not in ESM land. We have to say module. Let's do it this way. Module dot exports equals state like that. Okay. Nice. So now let's change our life points. And now if we go here, I guess we this for roles. So let's do some roles. And then let's change this to dice. And now we're getting updates and preserving our state because our state lives in a separate module. And that's the entire workshop that I have here in this GitHub repo that takes us to build that whole thing. So now if I show you the implementation that I had in the solutions, you can see that, yeah, word count -l, we're already in here. Yep, so this is being done with 47 lines of JavaScript. So we're not doing too much. And the reason this is so small is we're not really doing, production grade robust HMR here. We're just kind of showing the main concepts, kind of like that differential model that I showed you guys in the video. So what's kind of missing from real production grade HMR? So one thing is we're not really handling files being added or removed. We're only handling files being changed. That's kind of an exercise that if you want to go ahead and do, you can do it. It's pretty straightforward. The other thing is we're not handling errors gracefully. So if I do something like over here, I've got my app running and I go to, let's go to health and let's make like a syntax error. Like if I do that, right, this actually crashes the HMR server that we have, and we can't recover from it just by fixing this, right? We actually have to like rerun the server, which is kind of annoying. So you could put like try catches around some of the retry logic in our HMR, and you can display a little message when things are wrong. You could do that too. So that's another thing that we could do. Something else is there's this whole thing called the HMR API, which was super confusing to me when I first saw it. So one thing that's happening here is like, if you imagine we go to, let's go back to the roles state. Yeah, this one. If we change this and we start saying, I actually want this to start with 6, 5, 4, 3, 2, 1, right? And now I go here, great, it updates to that. And actually, I want 7. I want actually a 7 here. And I want a 2 here, and I save that. It gets rid of it kind of just full replaces the entire history of my dice rolls, which is like one possible implementation. But maybe when I change this, what I want is anything that was here gets persisted and the things that I changed get added onto the end or something like that, right? There might be like more than one correct behavior for how HMR should work. And it might depend on the app to kind of define that. And so that's exactly what the HMR API is for. So if you look at the HMR API, for example, this is a really good reference for it. There's all these methods like accept and dispose and invalidate. And these are all hooks that you can use. Let me just make that a little bigger. to deal with what happens when a specific module is going to be invalidated. So if you wanted to accept the new module and append things to that list instead of replacing it, you can use this callback function, and you can get the new module, and you already have access to the old module, and you can like do all sorts of fancy things there. My goal here is not to explain exactly how this works, just that it like exists, and that this is like a thing you might want to think about, is that there's more than one correct way to update a module. So that's something else that you might be aware of. And then the last thing here is like ESM, right? So we're doing all this stuff in CJS. Like, how would you do this stuff in ESM? So the big thing about CJS is that we have the require cache, and that let us do things like invalidate the require cache. So we saw code like this, which was really nice. That's exactly what we wanted. In ESM, we can't do that because we're not using require. We're using import. And so the trick that ESM uses is they use an import for whatever module you're importing. In this case, we called it stuff. But I've got this query parameter with a timestamp, usually called T. And usually this is like a full timestamp, but to fit it on the slide, I just said 1, right? And the important thing to know about this is that the ESM import cache looks at the query parameter, and if it's different, it actually doesn't take the cached response. It gives you a new response, which is nice. And that's how you can get new things to come in and not respect the import cache. So if we changed our title or our health and we re-imported it, we want to make sure it's the new one. One thing to note about this, though, is that this doesn't actually get removed from your memory. So if you do this over and over and over, like your memory usage goes up. Whereas with the require cache, if I go back to that, this actually, I think, does free up memory whenever you delete things from the require cache. So there's a slight caveat there. But you probably don't have to worry about this. Like most of the time, the framework that you're using is doing this for you. But now you know, if you look at the browser tab and you're using Vite, like why are there $T equals things all over the place when you're getting HMR updates? This is exactly why. They're trying to invalidate the import cache for ESM. So the last thing I wanted to mention about this talk is I titled this, "What the heck is HMR anyway?" And I got this title, which I shamelessly stole from this excellent talk by Philip Roberts. Not related to any of the stuff I talked about today, but it's a really excellent talk. And it also kind of shares the same philosophy of making something complex and just focusing on recreating the simplest fundamentals of it to understand it. So I really recommend you watch that if you haven't already. And yeah, there's a lot more complicated things that you might want to deal with in a real HMR use case. Like I said, we're doing this all in Node, not in the browser or over the network. So if you wanted to do this over the network, you'd have to find a way to send modules over the wire and things like that. So it gets a lot more hairy and a lot more complex. I've actually got another repo called HMR from scratch where I do that serialization step. But man, that would be like a 4-hour talk. So this is like the shortened version of that. So yeah, that's kind of mostly what I wanted to talk about. HMR is super powerful. It's not that scary, but you know, rerunning modules all over the place is also not free. So there's some trade-offs there to understand for sure. And so my hope is that by understanding what's exactly going on here, that you feel more confident and comfortable using HMR in Vite or in Webpack or in Remix or wherever you see it.
Awesome. We have one question in the chat from earlier. Actually, from the beginning, it's what's the difference between HMR and HDR, hot data replacement?
Yeah, that's a great question. So what I just showed here was the concept of HMR, not really in a browser or server context, because we were just in one context. We're just in Node the whole time. So we didn't have to think about the fact that there's these two contexts. Usually when people talk about HMR, they're implicitly talking about HMR in the browser. So you change like your app code and you want to see that app code reflected in the browser. And that's how HMR was originally designed. So if you were working with an SPA or a completely client-side rendered app, HMR worked great. But with Remix, you have a full stack app. And so if you change your server code and you change your UI code, and the UI changes you made depend on the server changes you just made too, if you just send the UI updates, it's going to be requesting things that the server doesn't know about yet because the server hasn't updated yet, right? You're only updating the browser. I've got a full talk on this from RemixConf 2023 that goes into it a lot more detail. But that's kind of the short of it is when you've got a server and a client, you have to make sure both of them get updated. You got to make sure the server's updated before the client asks for the new data from the server. Otherwise, it's going to get the old data. So there's a coordination problem there that's really hard. And that's something that we've solved through HDR. So that's hot data revalidation. And so the key takeaway there is that right before you apply the updates for HMR, you first fetch new server data. And that only works if the server has the new data, which means the server has to be updated too.
Nice. Hey,
Okay, so it looks like there's another question from Clifford, maybe.
Yeah, you got it.
Yeah. How do you see HMR's future being impacted when React server components become stable? Was there anything surprising or interesting when moving from Remix v1's hand roll to? Yeah, so let's go through these one at a time. So first one is about RSC and how that impacts HMR. So it's actually kind of interesting because RSC is like another mechanism for sending like diffs of your app to the browser. And so I was kind of excited when RSC came out because I was like, ooh, I could use that under the hood to be the mechanism by which I send app updates to the browser for HMR. But they've got kind of different use cases and they're designed for those use cases and the trade-offs are a little bit different. So I think HMR will still be around even when RSC comes into the picture. So the idea is like whenever you're doing, whenever you're not making changes and you're just like navigating through your app, RSC kicks in. And then whenever you're actually like making a change live in dev, HMR puts those changes up, right? So that's really how I think it's going to work until, yeah, maybe someone will crack a way to using RSC for HMR, but I think they'll stay separate concepts for at least a little bit. And then, yeah, was there anything surprising or interesting when moving from Remix hand-rolled HMR to Vite's HMR? Pleasantly, no. Like it was like pretty nice. So Remix had to build all of the HMR machinery from scratch. So it had to, you know, when you're doing things over the network, you have to set up like WebSockets to communicate these changes. You have to listen for those. You have to like set up a module system on the browser side. Like it's a lot of just like grunt work to just get the basics going before you've even added any information about how Remix wants to do HMR. And with Vite, all of that grunt work was kind of done for us. Like all the WebSockets were all set up, and we could just use those. It also already has like the bubbling built into it. So as soon as you like send an invalidation to the browser, Vite already understands like what things depend on that and what things should like be bubbled up and called. So that's really nice. We didn't have to build that either. And now let's see. Have you seen or heard of any innovations in the HMR live reload space as of recent? I mean, Vite's always innovating in like performance optimizations and little things here and there. I'm obviously biased because I've worked on HDR for like 5 months this year. So I would say that HDR is a big innovation. And yeah, I think to summarize the experience there is the goal is you change code in your app and no matter what you expect should happen on the page. Right? That's really the like the thing that we want to give you from a DX perspective. And yeah, we kind of think that HDR right now is necessary for that.
Awesome. Very easy question. I found the answer in the package.json, but maybe you want to quickly explain why there is a pound sign in front of your imports in your demo.
Yeah. Yeah, so I wanted to make sure that we were exercising a real project. So if you look in package.json, we've got import aliases. So I have a pound sign that just maps to kind of the root of this repo. And that's important because here, when we're doing require, if we were doing something a little less smart, and we were trying to like analyze these imports in a trivial way in our HMR script, you'd be tempted if we weren't using aliases to just treat these as like the file paths. But that's not a really realistic use case. A lot of people have aliases and things like that. So you need some like robust way to resolve these things into real paths before you operate on them. So that's why that's in here. So it's not only like a little bit more ergonomic for this project, but it also shows off that we're handling aliases too, and we're resolving those correctly for HMR.
Nice. One more question from my side. I mean, the delete require cache is probably easier to understand, or like it just reads clearer in the demo. But is there any other reason why you chose CommonJS over ESM for?
Yeah, the other reason, well, I mean, it's not only that it reads clear. I think it's just that the issue with import is that import. How do I explain this? In CJS, if you just require the root of your app and you've invalidated the correct things, then the whole thing gets updated smoothly, right? But with the import timestamp trick, you'd have to like manually import all of those things separately, because that's not an invalidation mechanism. That's like it's like a declarative API instead of a procedural one. And here, like the procedural one's kind of the one we want. The other reason I use CJS actually is because when I first started digging into this, I didn't know any better. So I tried implementing this across the network first, because I was like, how hard can that be? And yeah, you have to serialize things and you have to make your own module system in the browser, unless you do really fancy things like Vite does. And so I basically re-implemented require in the browser. And the reason that's a lot easier than implementing import is because require is just a function. Whereas import is like a statement and you need like parsing logic to make it work right. But if you just if you just define require at the top and then you run your code as CJS in the browser, it's fine. So that's kind of the other reason I did it that way too.
Cool. Any other questions from anybody?
They don't have to be about HMR either. If you guys want to just talk about Remix or anything like that, happy to answer anything.
How's the weather in Washington, D.C.?
Oh man, it's cold and dark.
I have one more question, I think.
Mm-hmm.
In the lib folder in your browser file, where you handle the socket, I think what I'm reading is basically you pass down the socket, and if there's a signal, it's just call your re-render function, right? If I saw that correctly.
Mm-hmm.
How would that work with the browser? Do you hook into React on the browser side to trigger re-render, or how would you do that?
Yeah, exactly. So in the browser side, so I think this is what we're talking about here, right? So yeah, if socket listen, handlers render. So this is just saying like anytime we call socket send, re-render the thing. And here's an implementation detail I didn't show you guys because it's inside of the browser library, but the render function returns the event handlers that were part of that frame. So if there were any buttons on the page or whatever, those event handlers get passed in. So that's just an implementation detail. But yeah, it's pretty much the same thing. Actually, we can actually take a look at exactly what that looks like. So if we look at, let's go to Remix. Let me make this big. There we go. And let's go into the refresh runtime, refresh utils. Here we go. Where is it? No, it's going to be in Vite plugin is where it's going to be. Yeah, here. Yeah, okay. Yeah, so this is like a bunch of code that we inject for each of the modules in like your wrap modules. And it's kind of ugly because it's like inline code or whatever. But at the end of the day, we have like callbacks. So we're using the import meta hot accept. So this is the HMR API that I was talking about earlier. And so we're saying like, whenever Vite tells us that there's like new stuff about this module, like the server has told us that stuff, like here's what you should do. And part of what you should do is you should use the refresh runtime, which is React refresh, and you should let React refresh handle updating this thing. So that's kind of the other takeaway here too, is like one thing is just updating modules in general, and JavaScript has like a lot of semantics there. But if you know that your module is mostly a React thing, like it exports only components or something like that, you can actually just delegate that updating to React. And that's what React refresh is all about. So that's what we're doing here. Whenever the server sends WebSocket things about this function gets called. We've got the exports for the new version of the module, and we just let React handle that. And so it's going to know how to swap React components out for us and preserve all the React state. So all that stuff that we were doing in our code to like invalidate and make sure and keep the state over here, not over there, like React just knows how to do that for React. So we just delegate it here.
Thanks for sharing. That's awesome.
Yeah. And actually, maybe one last thing I can share is, I think we have it here, don't we? Question mark T equals, maybe RG question mark T equals, we can say packages. Oh, do I need to escape this thing? Probably, right? Yeah, so that trick for ESM that I mentioned, you can see it like in use right here, right? So we're doing an import. Here's the thing we want, but if we just get that thing, we'll get a stale version. So we add a timestamp parameter and we add like a timestamp to the end just to make sure we get the latest one, right? Same thing here for the Vite work. We do the same thing as well. So that's just the thing you have to do for ESM, unfortunately, but that's the best we got.
Awesome. Cool. Let me stop the recording, then we can still hang out for a little bit.